Good evening, everyone. So, first of all, I would like to uh, thank Dr. Dootika for giving me this opportunity. Because I feel like, I came here only today morning, and I feel like I'm the only one who is not a mathematician here. I, I have given the same lecture to art history students and fine art students. But this is the first time I'm going to talk to mathematicians. So I had to pick up some courage to do this. So, the presentation is going to be it's going to be about my art practice, art history, and also mathematics. So I think that's how I have structured the um, presentation. So this is like one of my favorite quotes. Mathematics rightly viewed possesses not only truth but supreme beauty. So uh, I think the key word for me is the rightly viewed, right? The word rightly viewed. So I'll just give like a brief biography of myself. So where did I get that uh, like the power of rightly viewed, the keen observation? So I think I got it from my grandfather, who's an entomologist. So he was a chief entomologist in the malaria department in Tamil Nadu. So even when I was a kid, I was able to distinguish between mosquitoes which had malaria and which doesn't have malaria. So my grandfather taught me that. So he was able, he taught me the the virtue of keen observation. Keen observation. Yeah, you'd say that. So I think from that young age, I was able to whatever I'm seeing, I was able to observe very keenly. I think that's what made me uh, follow mathematics for inspiration. So I'm going to give some quotes from the history of science, and then I'm going to show some of my works and works from art history. So I've been practicing art for the last 13, no, 12 years, I would say. Yeah, and the 12 years for the mathematics entered my practice uh, around 6 years ago. So the first thing, like some 6 years ago, I got a fellowship to go to Italy to study the Renaissance art and architecture. So only through Renaissance art and architecture, mathematics came into my practice. So here Kepler talks about the Pythagoras theorem and the golden ratio in this quote. And I was really interested in golden ratio because I saw all these paintings in person. Before that, I've seen it in books, but only when I saw it in person, when I went to Italy, that's when I the composition of all these paintings, they kind of struck me. Uh, I was thinking what made all these artists to make these fantastic compositions, and then I started reading about it, and many of them use this. It's called a golden spiral. I'm sure that you guys know about it. So, this golden spiral was seen in many of the works which I saw. Like this is one by Leonardo da Vinci. Again, this is by Johannes Vermeer, and again by Leonardo da Vinci. So, time to time, I was able to see the recurrence of this golden spiral. So I wanted to do some work based on that, some work based on the spiral itself. So here the spiral was just a tool for constructing the composition, but I wanted to use the spiral itself in some way. So these are some of my works from 2021. This is like a huge wall installation. It's almost this size, like the size you see here. So it's like an installation which I displayed in a gallery in 2021. So here, so you can see there is also a golden rectangle, right? Around the spiral, there is a rectangle. So I started cutting cardboard in that rectangle, which is like a golden rectangle. And then I started playing around with it to get different compositions. So when I get the right composition, when I feel it is right, I stop there. And then I start drawing the golden curves inside it. And I also started adding these meshes to get some interesting push and pull happening. Like you can see, it's almost like three-dimensional. Like these spaces, like for example, this one is like coming towards you, and the black portion is going back. So I was interested in those things. So this is the first time I started using like some kind of mathematics as a base to start with. This is one of the larger versions. And I was very fascinated by that. And then I think the next series, the blue is actually not right here. It is actually the blueprint blue. You know, the blueprints which we use for construction. It is exactly the same color in person. I think the projector has some color differences. So I wanted to use the golden ratio as a architectural element. So I started making these, I call these as impossible structures, because when you see them, I just used golden ratios one on top of each other and connected, the golden spirals one on top of each other and connected each one with another one to create like a three-dimensional an object or a space. But I don't think it is quite possible to have it in the real space. I think it is just for the sake of blueprint. So that's why I call it as blueprints for impossible structures. So you can see this is a zoomed in version. So this, so I had like a solo exhibition of these drawings. I had around 20 of these drawings. So in one of the galleries, I showed all the drawings. So this gallery is known for its architecture. So it has like a very rigid, straight 90-degree and like a tapering roof and all that. So in that gallery, like having this sort of like an impossible structure, it was like a good oxymoron, I would say. These are again some more the same series, but black in color. Only after this, I started studying fractals. So you can see this itself is a fractal. So you can see, so this golden spiral itself is a fractal. So this is another series where, so you see how I have cut up the golden spiral, right? So I have drawn like a 45-degree bisector in order to cut each of the quadrants. And then I started reassembling them to get new shapes. So these are all like the black shapes, which are, I would say, redesigned golden spiral. So it's a golden spiral, but I have cut it up with this bisector and then rearranged it in order to get these black shapes. I made around like some 150 of these drawings, but I'm showing only 20 here. So, and also the way I have arranged it, it's in the Fibonacci sequence, which will give you the golden spiral. So it's 1 + 1, 2, 3, 5, 8. So it goes on. So only then I started studying about the fractals. Then I came across the Mandelbrot fractal, which is like the first computer-generated fractal art. This is that. So you can see the fractals of Mandelbrot. This is, so only recently I started reading Upanishad and Vedas. And I found this there, and I just want to interject that here. So whatever is in microcosm is also in the macrocosm. I think that's practically a fractal. And this, when I went to Italy, at that time I was not really interested in fractal or mathematics itself. but I saw this. So this is this is in Rome, and this one is in Vatican, which is close to Rome. I saw this, but I was not really interested. I didn't know. I mean, I was not. I just saw that, okay, these are like nice patterns. That's all. Only later, when I was studying fractals, I came to know that this is actually like a major thing in fractals, the Sierpinski fractals. I was really fascinated by this. I was fascinated by the structure of this, and also it made me like a deja vu kind of connect. Like I was like, yeah, I saw this in Rome, and then suddenly it's again appearing in my research. This is the Sierpinski fractal. So this is the paintings I made. These are actually I showed these in Bangalore in 2022. Yeah, I showed it in 2022. So I started cutting papers to make a Sierpinski fractal, but I was more interested in the new geometry I was getting in it. Like for example, a shape like this. So I was more interested in that more than the fractal itself, where the triangle keeps repeating. I was more interested in like the very niche geometry I am finding in this. So I made this series of paintings, or collage, I would say. And then I wanted to make a three-dimensional version of Sierpinski fractal. So that's when I did this. So this is a like a equilateral triangle prism, and then I painted it in the Sierpinski fractal pattern. So this is the show actually. So this is the show happened in Bangalore. So you can see the paintings in the back, the sculpture in the front. When I was reading about fractals, I came across this letter written by Leibniz to D. Bosses, so who's a Jesuit theologian. So he wrote a very interesting geometrical phenomena, I would say. He said, like, imagine a circle, inscribe within it 3 circles, congruent to each other and of maximum radius. Proceed similarly within each of these circles and within each interval between them, and imagine that process continues to infinity, right? It's the same thing with Sierpinski fractal. But the only difference here is it's a circle, right? It's not a triangle. And you get a shape like this. So actually, Leibniz had sketched like a very rudimentary version of this fractal, which I didn't include. So it's very similar to Sierpinski fractal, but in a circle, right? I was very interested in this. So I wanted to play around with this fractal. So I asked one of my like geek friend to write me a program to give a fractal. I mean, to get an image of this fractal, because I needed like a very high resolution fractal. I mean, the shape of this fractal. So he did that for me, and then I started making screen prints of it. So screen print is a method where you can it's like a handmade print, I would say, rather than a machine print. It's a handmade print. So I started making screen prints of this shape, and then I started cutting around it. Like I started like slicing it through various radii and like half, quarter, 1/3, and all that. And then I started putting them back in order to get these like new shapes. Like you can see, it is quite different from this, right? Like I started getting new shapes out of that that Leibniz fractal. So when I cut it into 1/3 and then just made like a 90-degree rotation, I kind of get this like a hexagonal shape. So it was more like, I would say, mathematics was a toy to me. I was like a kid, and I was like just playing around with it and getting new things done. So this is another one. So I just made 4 of Leibniz fractals intersect at one of the edges. And then this happened. So when I was reading about this, so this is also called as circle packing. So there is a separate subject called circle packing. I came to know that only after studying about it. And then there is another art form which uses circle packing in a very effective way. Can anybody tell what is that art form? Mandala, in a way, it is. I'll give you a clue. It's Japanese. It's a Japanese art form which uses circle packing. Origami. So origami uses circle packing, which I never knew, because I mean, at the first glance, it just looks like it's folding of paper, right? But when you think about it, it's circle packing. So this is the crease pattern of this insect. You can see how circles are packed, right? And then I made further research into it. There is actually a computer program for that. It's called a tree maker. So in Tree Maker, it's by this physicist origamist, Robert J. Lang. He developed this program where you can just draw a tree like this. For example, if you want to make a spider has like one body and 8 legs. So you draw a tree like that, with one central line and then 8 appendages. You will get a crease pattern like that. And when you fold it, it becomes a spider, right? So pretty much anything can be folded using this tree maker. And the tree maker works with the principle of circle packing. So I was really fascinated by that. So I wanted to do something with that. So that's when I did this. So this insect cicada. So cicada has a relationship with the prime numbers. So cicadas, they come out of the ground every 13 years or 17 years. So it is called as the predator avoidance. Yeah, predator avoidance theory. So when they come during the prime numbers, so usually most of the predators of cicada, they have a hibernation of 2 years. So they come out of sleep every 2 years. And if cicadas come only during the prime years, that way they will avoid that avoid that predator, right? I was really interested. So somehow I landed up in this fact. And at that time I was doing this research. So I thought, why not make a cicada out of origami? So I made a cicada out of origami. I actually have this here. You guys can look at it later. I have the origami cicada. This is a close-up of it. And also the graph behind, that's all the prime numbers in that graph paper. So you can see 2, 3, 5, 7. So all the prime numbers are shaded with graphite. This is actually I didn't get a good image. So this is the crease pattern for this cicada. And you can see how circle packing plays a role here. And then when I was studying about circle, then I moved into circles. I was very interested in circles. And then I came across this poetry of Dante, so who wrote Paradiso. So Paradiso is one of the great epics of Italy. So in Paradiso, he says, as the geometer, his mind applies to square the circle, nor for all his wit finds the right formula, however he tries. So even the English phrase, squaring the circle, so it almost means when you do an impossible task, we say, don't try to square a circle, right? So I was interested in this formula, this mathematical problem. So I think everybody knows about this problem, right? Squaring the circle. So you have to if there is a square which has X area, you have to draw a circle with the same area with finite number of steps, just using compass and set square. So it's an age-old problem. It's dates back around 2,500 years, and the Greeks were the math leaders. So Leonardo da Vinci tried to solve it using a very empirical method, not mathematical method. So you can see here, he tried to solve it using the human body as a tool. So you can see, I don't know whether it is written here, but in the codex, in one of the pages he has written that this square and this circle has the same area, and he used the human body to draw both of that. So you can see when he draws the circle with the navel as the center, and then he draws the utmost width and length of a human body, so that becomes a square. So both are equal, but it's a very empirical method, no finite steps, not mathematical. I made this based on that. It's a steel sculpture, so it's a pretty small sculpture. It's like this size, and at that time I was also reading into a lot of mythology, and then I came across this Quranic verse, like eyes cannot reach him, he reaches the eyes, he is the incomprehensible, all aware. So he is incomprehensible, right? Like this problem, like how this problem is like unsolvable. And also, I mean, for your information, this problem now it is deemed impossible. Like it has proved that it is impossible to do it. So it's a impossible problem. You cannot have a solution. So, I mean, as mathematicians, I think you guys can tell me why is it unsolvable? I mean, I read about it. I know quite a bit, but I don't think I know as much as you guys. So anyway, we can talk about it. So yeah, so this steel sculpture, I made it based on this quote. So how the problem is unsolvable, and also the Kaaba, right? The Kaaba, which is in Mecca, Medina, which is like a black cube. So I took I made a black cube, a steel black cube, and then I drew a circle on top of it, which is like almost to the area. So that the area of this square, area of this square, and then this circle, they are almost the same. So it's pretty much like a solution to it. It is not a right solution, but pretty much a solution to it. So it's almost like equating, I mean, in this phrase, he kind of equates it to God, this problem to God. I was kind of doing the same, but in a different way. So this is so this sculpture and this painting, it is shown together last year. So it is again, I tried to, like, I took a circle and then tried to fit like many of this squaring the circle inside it. So you can see there are like 8 squares and 8 circles inside a circle, and then it creates another circle-like shape here. So I was kind of interested in that. I made this painting for that. And then last year, 2024, during the summer, I was in Hampi. So I was awarded a residency at Hampi, so which is given by the JSW Art Foundation. So I stayed in Hampi for around 3 months, 3 to 3.5 months. So at that time, I was kind of, I mean, every day we used to go to these temples. I mean, Hampi has like a lot of temples. So it's almost like every morning we'll get up, we'll go and explore these sites, and we'll come back to our studio and make art. So that was like our like agenda for like 3 months. So one thing I was inspired by was this Gopuram, which is like you can see it is kind of like a fractal. The same thing is like repeating again and again in different scales. So I was interested in that, and also another kind of circle packing I saw at Hampi. So you can see here there are like 1008 lingas packed into one space. And also this is the first time I was, there is one little push in my life, because like I was going to temple every day. I was like kind of like spiritually I'm entering that place. So spirituality and the thirst to know more about religion, it came to me during this period. So this is when I started reading Vedas, Upanishads, and all that. And at that time, I read about this. I'm sure that you guys would have read about this too. So this is called as the Einstein shape. So this is a aperiodic tile. So a periodic tile is where when you tile them together, it creates a pattern. So an aperiodic tile is one where it will not create a pattern. So when you tile these pieces together, it doesn't create a pattern. It is like an infinity of uncertainty. It is always uncertain. Like you cannot like put a certain pattern into it. So I read this research paper when I was in Hampi, and Roger Penrose tried to solve it, but he couldn't do it. Rather, like a math hobbyist actually solved the problem. His name is David Smith, and that's where like as I said, I was reading a lot of religious text, and this was like the Thiruvatturar Puranam. It's a Tamil literature about Lord Shiva. And here you can see our Lord is the dancer who, like the heat latent in the firewood, diffuses his power in the mind and matter and makes them dance in their turn, right? So I wanted to make like some kind of imagery for this, the cosmic dance, right? I was reading a lot about this cosmic dance. And I wanted to use some kind of imagery to it with some imagery of mathematics in general. So as I said, I was reading about this, and then I was reading about this. Then I thought, like, how can I merge them both? And then I did this. So this is like, one of the, it took me so long to finish this, and also I literally destroyed myself doing this. So you see each of this tile, they're all like a ceramic tile, which are like hand cut into that shape, into that Einstein shape. I have around like 500 tiles here. I think around 500. No, not. It's I think 400 tiles here. And one thing about the Virupaksha temple, which is in Hampi, is that that lingam is like a Swayambhu lingam. Or Swayambhu lingam is when it is not like carved by anyone. It is just found. So they just found a rock which looks like linga, and then they have sanctified it, and it becomes like the major idol of that temple. So I kind of like that idea. So I went into the UNESCO site, and then took one of the rocks, which later I came to know that it's illegal to do that. But I found one rock, which is kind of looking like a Shiva image. So I took that rock from the UNESCO site, kept it in the middle, and then I started making these tiles. And then I kind of made it into look like a dance, and also the hair of Nataraja, like wavy and ever growing thing. And also like one of the things is like in in Hindu literature, it's almost like we say that God lives in a cosmic space which is infinite. So again, here the idea of infinity comes with the aperiodic tiling. So in aperiodic tiling, there is no certainty of a pattern. So it becomes infinitely uncertain. So I was kind of interested in that idea. So here you can see it looks like a dance, like, and also the Nataraja's like the hair. At the same time, it also looks like this rock is floating on this cosmic space, or the Einstein tile space. So that's why I named it cosmic landscape. And I was there for 3 months. This whole project took me a month actually, because I had to like individually cut each tile. And also the problem with ceramics is like it is also very uncertain. When you put it in the kiln, you don't have 100% surety that it will come back intact. So I broke so many tiles in the process, and only this many was left. This is me putting it in the gallery. So I had a show with this last year. So here you can see I am placing the tiles. Also, I made the same with steel. So this is laser cut steel. So I made a drawing, an AutoCAD drawing, which so here you can see it doesn't have a pattern. So here you can clearly see that it doesn't have a pattern, but yet it fits perfectly. And I named it Big Bang because like when I was playing around with AutoCAD, I found this thing, right? So when I put 4 Einstein tiles together, and then when I moved, when I like in the AutoCAD there is a there will be like a small pointer. When you move it, it will become a curve. So when I pulled it by mistake, that is like I got this shape, which is almost like a sparkle. So I kind of like that idea, like how Big Bang happened. So there is like a sparkle, and there is like infinite expansion. So that's how I see it. So there is like a sparkle in the middle, and then infinite expansion. Now, actually, right now I'm working on a piece similar to this, but it is going to be more than 7-8 feet. Like this is like only like 3.5 feet, but like one of the collectors really liked it, so I'm planning to make it in very large scale. And then one of the other things I noticed in Hampi is this: everywhere there was this gaming board which is carved in the temple floor, which was really striking, because I have seen it in other South Indian temples. I have seen it, but not in this quantity. In Hampi, it was like everywhere. Like in whichever temple you enter, there will be this some game board. And I don't know what games they played at that time, but I was really interested in the idea of playing a game inside a temple. That too, playing a game of, and also in all these games, most often there was a die involved, a dice. So it is like very uncertain since it involves a dice. It's very uncertain. So I was kind of interested in this idea where uh, so you go to temple in order to uh, overcome your uncertainty in life. You are uncertain about something, you go to a temple. But there they were playing a game which is based on uncertainty. I was interested in that dichotomy. And then I started reading about, at that time I was reading Stephen Hawking's book. So there, I mean, these two were there. So Albert Einstein said, God does not play dice. But Stephen Hawking said, I mean, he questioned, God does play dice. I mean, it's a question. When, because of quantum mechanics, because of the electron's position in electron's position and velocity, Stephen Hawking asked the question whether God does play dice. Right? So I loved this opposition too. So I made this work. So in Tamil, so I'm from Tamil Nadu. So from Tamil, Kattam means these are called Kattam. These things. These things are. So I made this work, and also in most of the architecture in Hampi, the temple architecture, the grounds were, I mean, the floor were made up of granite. So I like ordered a granite which is of like a perfect cube, which is like a dice, and then you see this is only like 10 into 10 into 10 in dimension inches, but it is extremely heavy. It is, I would say, probably around 80-90 kilos. Only like I had to have like 3 people to just move it little by little. So and then I started playing dice with this brass dice. So you can see the brass dice here. So you see there is like a geometric forming, a geometric element forming here. So that is based on chance. So I keep rolling the die. If it is a like a odd number, then it will be placed vertically. Then if it's an even number, it will be placed horizontally, right? So that is how I got this shape. So probability designed this shape. So I was very interested in that. So it is not me, it is probability which designed this shape. So again, it is like ode to this question, whether God does play dice or does not play dice. And then I was always interested in the idea of limits or like limitation. Like when you are like limited by something, I feel like there is a greater freedom there. I was interested in that. So, and I'm going to show you one of my favorite artworks. It's by this American artist named Soluvit. He's a minimalist. Minimalism is a art movement which happened in the US during 60s and 70s. So he is one of the pioneers in that. So he did this series called The Variations of Incomplete Cubes. So I think by seeing it, you might have understood. So it's like he takes a cube and then he keeps removing the edges and he like records each of the variations. Like he will remove one edge and then draw that. He will remove two, he will remove three. So that way it keeps on going, right? And then he also turned them into sculptures. You can see these are the sculptures. These are small ones, but I have also seen very big ones, like probably size of the screen. He also made sculptures that big. So I was very inspired by this. So I made my own version of limits. So I made a series of, when I was in Hampi, it was like a very, like a serendipitous thing. Like I was in Hampi for exactly 89 days. And I decided to do one painting every day. Like based, like setting a limit for myself. So the limit is that I have to use at least 5, what do you call that? Like a golden ratio lengths in it. For example, like this, like all the 5 lengths, they are in golden ratio, 1:1.614. So for example, here, this length and this length are in golden ratio, and this length and this length are in golden ratio. So golden ratio became a limit. I decided to work within it. Like it's like I should not go like beyond it. So I made a series of 89 works. So all these works, each work every day, it involves golden ratio only. Like the ratios between most of the lengths, they are lengths and breadths, they are in golden ratio. And I use the word serendipitous, right? That's because only after finishing this work, and I came to, at the 89th day, I left Hampi. 89 is actually a golden number. So it's after 55, it's 89. And then another thing happened. So I got married last year, and with my wife, I mean, we wanted to have some like a hobby with which both of us can share. So we started playing chess. We started playing chess every day, and it was only like for a week would have passed, and then like one day I got a call from a woman, not a call, a message actually, a message from a woman saying that her whole family likes my work, especially her son. Her son is like 12 years old. She said like, my son really likes your work, and whenever you are coming to Chennai, please do come and visit us. I thought it's like, I mean, okay, maybe whenever I go to Chennai, I'll visit them. And then like probably some 10-15 days after that, I had a meeting in Chennai. So I went to that meeting, and then the meeting was over soon. And then I remembered about this lady. I said, okay, now I'm free. I will come to I will come. So she sent me the address. I went there, and then I opened the door. It was Vishwanathan Anand. So he was, it was his wife. So, and then, so both of us started talking about chess. It was like, I was telling him, like, I started playing chess only 2 weeks ago, and then now I'm meeting you. So, and then we spoke like some 1 hour about chess. It was like one of the best conversations I ever had. And then I like, when I was talking to him, since I told him like I'm really interested in math and all that, and then he kind of introduced me to this problem. So this is called as the knight's tour. If you guys know how to play chess, I mean, so this is the path the knight takes in order to touch all the squares, but only once. So this is the path. So you can see, right? Uh, this is the path in order for the knight to. But there are like, yeah, we'll come to that part later. So I was really inspired by this. I thought like, yeah, maybe I'll work with this. And also, you see there is like a quite a lot of symmetry. I mean, a similarity with an Indian art form called kolam. So it's a South Indian rangoli, which uses dots and paths. So I started doing that. So here again, I'm not a mathematician, but there is a mathematical way to solve it. It's called the Wondorf's. Uh, I think it's called the Wondorf's rule, but it is quite exhausting, and I didn't quite understand it, so I didn't go for it. So I wrote, with the help of ChatGPT, I wrote a Python code, and then I developed an app with Firebase. So with Firebase, you can develop your own apps. So with that Python code, I developed an app which can figure out the knight's tour even for larger boards, not just 8 into 8. So this is an 8 into 8 board, but it can, the app which I designed using the help of ChatGPT and Firebase, so that can solve bigger boards. So this is a 20 into 20 board. So you can see this one, it's a 20 into 20 board, and yeah, it worked. So it all looked like a column, and also I like the fact that, see, when I am doing it, I don't feel it, but when I finish the work and stand away from it, that's when I really see the beauty that it's one single line. So it's a one single line which travels through all the 20 into 20 squares. Also, it's a challenge to find the starting and the ending of the line. So now I'm actually doing, I don't know whether I have the picture. Before coming here, I was actually working on a board which is 36 into 36. And that's the Python code which I was using earlier, it couldn't solve it. So I had to feed it to ChatGPT again, and I asked it to do some debugging, and so now I was able to do it. Now I am actually working on a 36 into 36 piece. Yes. So now it goes to all 20 into 20 squares. In this, this is like each one is like a 20, 20, 20. So it's like 20 into 20, 20 into 20, and 20 into 20. But now what I'm working is like 36 into 36. And then, so at my home, my wife and my mother, they both draw the column in our, in front of our houses. So I thought like, my wife is also an artist, so I thought I'll also include her in this project. So she drew some knights column for me. And then these are the ones solved by the Python code. So these are like the entire chessboard, 8 into 8, and each one has 64 squares in it. So each one is like a solution to the knight's tour. This is the total number of knight's tour possible, and I have solved it only. I have solved only like 64 of them, and this, yeah, I don't know how to pronounce this number, so that's why I just wrote the number. I think it's 20. 2 quintillion maybe, I don't know, 2.6 quintillion, I don't know. So this is the number of nights stored possible. The one of the things that fascinated, even when I was talking to Vishwanathan Anand, one of the things that fascinated me was uh, like how chess involves a lot of big numbers, like huge numbers like this. And also uh, like there is a story where there was a king, and that king wanted to learn chess. So he asked, he announced in his kingdom that if anyone can teach him chess. And then one scholar comes to the king, comes to the court, and he said like, I'll teach you. And then the king learns, and the king was uh, like uh, he had a bit of ego. He said like, you ask me anything, I will give you. And the person who taught chess, that scholar, what he said was like, I don't want anything much, just like keep one grain in the first square of the chessboard, and then keep the double of that in the second one, so it becomes 2, and then in the third square it becomes 4, and the fourth square it becomes 8. So when it reaches the 64th square, it is more than the number of rice grains in the world. So it becomes a very huge number, right? So I was like this. There are like so many instances where people compare chess with very large numbers. I was interested in that. That's when I did this series of work. I don't know whether you guys have heard about this. It's called the Shannon number. So Shannon number is the total number of chess games possible. So this is like, so this number is more than the number of atoms present in the universe. So I started copying all these astronomical charts, and then like I told you, right, every day I play chess. So I choose one of the pieces when I am playing, and then I make a constellation of that piece, the movement of that piece as a constellation. But this chessboard is in circular format, not the usual square one. Because since the astronomical charts which I was seeing, they were circular. So I made the chessboard into a circle. And then I was like keeping record of my pieces, like how they move. And also it has written like which pieces are there. Like this is, I think this is bishop. I think this is knight. So I was keeping track of this. Yeah, now let's, I mean, that's all about my work. So I think now we'll talk about, and since I have introduced some kind of like cultural background of mathematics, religion, mythology, art history, and all that. So there are like 2 stories I want to finish with, like how mathematics was perceived by artists and I would say people who are controlling culture. So this is a very famous painting by William Blake. So William Blake belonged to the era of, this is called as the post-Enlightenment period. So like right after European Enlightenment was there. And William Blake is a very strong, I mean, he's a very pious Christian. He was like too much Christian, I would say. He has like gone out of way to uh, like yeah, he has gone out of way to help the church. So this painting Newton. So the reason he did this, he thought Newton was providing too much of reason and logic into the society, which he didn't like. So this is like an anti-Newton painting. It is not like he is commemorating Newton. So that's why you see Newton is naked here. He doesn't have a dress. He's not wearing anything. And also, what he has written about this painting is there are like the whole vastness is here. There are like so many things happening here. But Newton is not seeing that. Newton is so engrossed in his like geometrical solution. So it's like he's not seeing what is happening above. What is above? That is God. He's not seeing that. He's doing this, right? So actually, in the back of this print, he wrote this: art is the tree of life, science is the tree of death. So that's, but you should look at the year. It's 1795, right? I mean, at that time, I think probably a lot of people were saying this. And and the another thing is like both of them are English. So Newton was actually his fellow countryman. And also, William Blake has written like something on this line. It is not exact. I mean, I just took 3 words from that whole sentence. So he said like dangers of reason. Did you see that? It's a very interesting phrase. When you think of reason as danger, right? So I mean, I showed you some historical, art historical references where mathematics was used in a like a positive way, I would say. But here, William Blake is kind of against it. He is like against logic, against reason. And then another story I want to say is this. Everybody knows who's this guy, but who's this guy? What is it? No, no. What is that? Ah, not Heisenberg. No, not Schrodinger. Not sure. Hey, this is a clue. So he's actually a priest. It's George Lemaître. So George Lemaître is one who like he laid the foundation for Big Bang theory even before Einstein did it. What you can see here, both of them are together. So I mean the idea of the infinite expansion of universe. So that was proposed by George Lemaître much before Einstein, and the the interesting thing about him is like how William Blake was so much against science. He was against Newton, who was like the father of Western science. He was against him. But fast forward like 150 years, here they are. George Lemaître, who's a priest, standing with Einstein, actually standing like in par with Einstein, and also he was the George Lemaître was the head of the papal sciences. So Vatican has its own science department, and George Lemaître at that time he was heading it, and when they asked you like most of you would have known the history like how Vatican was suppressing science, right? Like they were leaning towards the geocentric theory, which turned into heliocentric theory later, which they accepted it only recently, right? So one day, interviewer asked George Lemaître, like being a theologist, being a priest, being a Christian, how are you able to do all this? Like how are you able to like do science and prove all these things which are like far beyond human reach at that time? And for that, he said these words: both the things lead both the roads lead to the same truth. Both theology and science, it leads to the same truth. So I just wanted to say I just want you to compare this story with this story. So in a span of like 200 150 to 200 years, a lot of things have changed, and I think even culturally mathematics, has been accepted and it's being used. Yeah, that's all.